Topic number 2 is locus. Locus is the set of all points that satisfy a given condition. So there's 5 basic theorems for locus, or 5 situations that'll always occur. So the first situation, or the first theorem, is whenever you start with 2 points and you want to find the set of all points that are equidistant from those 2 given points, the result that you get out is the perpendicular bisector. So you start with these 2 points P and Q, you're going to get out the perpendicular bisector. So the dotted red lines here represent the locus, and then the solid are the givens, or the starting conditions. So the second situation we had was if we want to find the points equidistant from 2 intersecting lines, we get out 2 lines that bisect the angles, and also 2 lines that are perpendicular. So these 2 red lines here are the locus, and those bisect each of the angles formed, as well as they're perpendicular to each other. So 2 lines that bisect the angles and perpendicular to each other. The next theorem is whenever you start with 2 parallel lines, when you want to find the set of points equidistant from 2 parallel lines, you get out 1 line that's parallel to the given line. So you get 1 line right between them. If you start with a point, so if I start with this point, I want to find all points that are equidistant from this given point. I get out a circle that's some distance away, which is the radius of the circle, from the center of the circle, which is that given point. So you get out a circle. In the last theorem, if you start with 1 given line, what you're going to get out is 2 lines that are parallel to the given lines, and they're the same distance away from those. So let's look at a couple examples. So this first example is a compound locus problem, meaning we have 2 or more loci. So a man wants to place a new bird bath in his yard so that it is 30 feet from a fence. So that's going to be my first condition that I need to satisfy. 30 feet from a fence. So I'm just going to put number 1 here. And also 10 feet from a light pole. So I have 2 conditions. I want to then figure out, so we have this diagram. I want to figure out how many locations are possible for the bird bath. So my first condition is that I need to be 30 feet from the fence. And then the second condition I need to satisfy is 10 feet from the light pole. So 30 feet from a fence, if you look, the fence here is representing a line. So my given condition is a line. So whenever you start with 1 line, you're going to get out 2 lines that are parallel, and it has to be 30 feet from it. So if this distance here represents 35 feet, I'm going to say this distance here is probably about 30 feet. So I'm just going to mark that as 30 feet. And I also need the same thing on the other side. So 30 feet on the other side. So you started with 1 line, we get out 2 lines. Then we go to the next condition. The next condition says 10 feet from a light pole. Here's my light pole. So remember, whenever you're looking at a locus situation, these objects, you're always thinking of it as if you were looking down at it up from the sky. So light pole would look like a point, and I need to go 10 feet from it. So if we said that this distance was 30, that means this leftover distance here is 5 feet, if this is 30. So that means I need to go 10 feet from the pole, so it's going to be maybe about here. So 10 feet from the pole in all directions is going to be a circle. And this would be 10 feet. So then the question is, how many locations are possible? Well, wherever your loci cross is a point that satisfies both conditions, and we mark those with X's. So I have 2 X's, or 2 locations that are possible for this bird bath, or 2 spots that are basically 30 feet from the fence and 10 feet from the pole. And you're always looking at where do the dotted lines cross, because that's your locus. So the answer to this question is there's 2 spots. So let's look at one more example. So here's a compound locus situation on a coordinate grid. So again, read the problem. On the set of axes below, sketch the points that are 5 units from the origin and sketch the points that are 2 units from the line y equals 3. Label with an X all points that satisfy both conditions. So first you want to identify what are the 2 conditions. So I see 5 units from the origin. Usually your keywords here are from something that's telling you what you're supposed to be doing from the starting point. And then it'll be separated with the word and. on the points that are 2 units from the line y equals 3. So we have our second condition and our first condition. So from the origin, remember the origin is the coordinate 0, 0. So you're going to start at 0, 0. You're going to go 5 units in all directions. So if you start with a point, you get out a circle because you've got to go 5 units in all directions. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 in all directions. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. And you're going to go ahead and connect these with dotted lines to form a circle. So the first one's done. Then we go to the second one. 2 units from the line y equals 3. So from the line y equals 3, this is a horizontal line. Remember, they're always opposite the axes. So I'm going to just draw a solid line going through 3. So here's my line, y equals 3. So that's my starting spot. I need to go 2 units from that line. So what that means is 2 lines, 2 units above it and 2 units below it. So 1, 2 units above, and then 2 units below. And I'm drawing these dotted because those are my loci. So now I just have to figure out where do my loci situations intersect and mark those with an X. So remember, it's only where the dotted lines cross. So there's 3 spots, and I'm marking them with an X. So in each of these 3 spots, I'm 2 units from the line y equals 3 and 5 units from the origin. So then that's it.